Okay, hi everyone. Welcome to this iteration of the robustness test meeting. Today is the 19th of June, and as always, we're going to try looking at some of the recent failures in robustness testing. We have a test grid dashboard now that shows us things in a nicer way, and it's also much more pleasant to view things in Prow than in the GitHub Actions UI, considering the size of the log, especially. So go back here. So this is the robustness testing dashboard. A lot of them are flaky, two of them are failing. So we can look at some of the failing ones. I look at this one. This is the first one. The nice thing about Provo is it parses the logs for us, and like it shows what's failed, what's not. I don't know if there's a better way to do this, but the way I usually look at failures in robustness tests is I usually like search for error. Um, I don't know how to do a case sensitive search. Oh, okay, let's do it this way. Watch broken. What? Yeah, there you go. So that's one, and that's one failure. So you can have three types of failures. Broadly, you'll see three types of failures. If something hasn't unexpectedly panicked. So one is you'll see a linearization failure. Here it says success, but it can be a failure. Usually that happens because of a timeout. Sometimes it actually happens because linearization has failed. The other is broken watch guarantee, which is often the case. So this is the error message that I usually search for, like broke watch guarantee, and then you see what's broken here. And the third is serializable operations are broken, which we don't see here, but that's one more thing that you can search for, like as text to sort of filter out errors faster. Um, okay, so let's see. We have broke watch guarantee reliable. So if you remember from previous meetings what reliable means. So let's see. If we go to tests, robustness, and watch it, right? We see.
I think you need to go back. It's yeah, here on the bottom.
Yeah, there you go. Yeah, reliable. So if you have a sequence of events and you receive, like if you have three events A, B, and C, A occurs before B occurs before C. If you receive A and C, the watch API guarantees that you will also receive B as part of it. But our failure tells us that guarantee broke. So we essentially missed an event from watch. So next we can try and see what that event looks like. So this is a little garbled. Um, if we come here and just like, okay, so we have a delete operation that's dropped. This, I feel like this is that issue that we hit last week. Okay, but we have a delete operation that's a delete event that dropped. The revision for that is 794. So this looks like operations that happened in the same sort of transaction because all of them have the same revision. Um, so a nice way to also look at that is like, uh, I don't know if this is the right artifact. A nice way to also look at that is if once you're on the test failure prow thing, you can look at the artifacts um, and look at the results that we have. Oh, I think I already downloaded it. Yes, okay. So let's see. We have results. I'm not sure which one I was looking at. Oh, so if you come across an error and you sort of want to see what test scenario has been run, you can look at like the log prefix here. So this is test robustness, exploratory HCD traffic, cluster of size 3. So if I look at my logs and look at the folder names, you will see HCD traffic cluster of size delete list. So this is the one that I should be looking at. And if I look at history, which is the visualization of linearization, this is what we'll have. And what was the revision number? 794. Right? So if I do rev 794, I should get so this is the transaction that we saw. Okay, let me see if I can split this. Also, I have a tendency to just go on and on. So just like stop me anytime if at all something doesn't make sense or I'm saying the wrong thing.
No, you're doing great.
Okay, so we have we have a put event that we got from the watch. We have a delete event that we did not get. We have a put event and we have a put event. So if I look at the linearization here for 794, which was our revision, so we have a put, we have a delete, we have another put, and we have another put. So we got one one put, two put, and three put. The delete is what we did not get. Um, and if I look at Rev 794, that I am quite certain that there should be a compaction that happened. And I will I'll explain why that may be the case. If I look at, let's see, compact. So we have a compaction here and a delete event for that same compaction that was dropped. Um, so just now to give some more context. So this is an issue that like Marek found in one of the robustness test runs 3 weeks ago. And there's been a bunch of discussion over here as to what could be causing it and things like that. But the root cause of it essentially is that when you have a compaction operation that is run, and the revision of the compaction is the revision of a delete operation, essentially, um, the watch in that one specific scenario misses a delete event. And this is there are a couple of options that are being brainstormed about like how to fix it. That is an ongoing discussion, but if a compaction occurs on a deleted revision, this is something that can happen. Like a delete event is what might get dropped essentially. And that's what I at least thought could be happening over here. Um, so if we can try digging a little deeper there, right? Let's see. This is for the okay. So these are our client histories and operations. So if you this is what you will see in any robustness test output essentially. So if I go to client one, for example, I will see a file called operations.json, which is essentially the key value operations that that client performs. So you'll see things like transaction, or you'll see a delete, you'll see a put, you'll see a get, and things like that. But the more interesting part is if I go to the server itself, which is each HCD node. So you'll see since this is a test with cluster size of 3, you will have three folders with each etcd node, basically. And within each, you'll have a member directory, which will have a snapshot directory and the write-ahead log for etcd. So if I do something like this, so this was like an earlier thing that I was trying to debug, but if I look for so this is a tool in the etcd repo. So if you go to the etcd repo, and if my internet decides to work, it'll be hilarious if I just drop off the call right now. But yeah. Okay, but basically, that's a tool in the etcd repo. Maybe I can show it locally. If I go to tools, you have a bunch of them. So this is the one. These are the two more relevant ones for robustness tests. So dump logs and dump db. So dump logs, you can read um, the wall and the snapshot files. Dump db, you can read the bold file essentially. So the bold db file. So if I do dump logs for compaction, I don't see anything, which is weird. But what do I get without anything? So you get like a bunch of stuff here.
You will get only entries
The recent
since the
one?
last snapshot, not all entries.
Yeah. Yeah, I was kind of hoping to confirm the way
There is
confirms.
you can use a flag. I don't remember the domain for index or revision that will to go. You can set it to 0, and then if you set it to 0, it will go from beginning of the file, or 0 of
Nice.
1 or 1, I think.
Okay. Okay. Maybe we can look at the logs directly. So we have uh, so if it is the same issue, what I should be looking at is if etcd panics, which robustness test sort of tries to make sure. Make sure as in like you have this thing called fail points inserted in the etcd code. So whenever we pick a fail point and we pick it randomly, so there are different types of fail points. You have fail points such as etcd can panic before a round of raft happens, or etcd can panic before compaction, or things like that. So whenever a panic occurs, um, when that node of etcd restores, if it restores from the revision that was compacted, and that revision was a delete revision, then you'll essentially see this type of failure, which is a delete event was dropped. And the reason this is important is, sorry, go on, Eric.
Yeah, I think that was my original assumption, but it was clarified by Benjamin. You don't need to crash etcd. It will always happen.
Yeah, yeah, that's true. That is true. So yeah,
Yeah,
this will be
yeah.
producing.
The best way to look at like the latest state is Benjamin comment about like the minimal reproduction. Yeah, yeah.
Yeah, I'll
The
drop a link
minimal
in.
reproduction is just you can use it locally. Like you can two terminals, no fail points, not everything. You can just like trigger it on local machine. Okay. Are there any questions from anyone else about this issue? Is this something that have everyone heard about this, or is this something new that would be good to know? Because I'm trying to understand if like when we announce the issue, people know that there is an issue.
did the like did the process of debugging or figuring out what to look at, where to look at, make sense? Because honestly, it took me a while to come up with how to do it. It was not very easy,
Mm.
and I'm sure
Mm.
it's subjective. Like each person does it differently. But in case something didn't make sense, let me know.
For me, it was great. Thank you for that. I think it's like you said, it's a very personal thing, and it's great to see other or I mean, not a different approach, but this like getting to the same results, like from context of someone else looking into it. Um, yeah. So I don't know if there is anyone else that. Was the investigation clear for everyone else? You can.
I mean, yes, for me, I learned a lot about figuring out how to uh, find that uh, or how to find where is the issue coming from. And for example, he searched about the letter error in the logs. That is very helpful. I didn't know that. I always go from bottom and search for the errors, and I mean that will help in future for me. And I personally have a problem about knowing context about HCD, about, I mean, I don't exactly, I know, but I don't 100% know about compaction. I mean, my approach is to learning about HCD more so I can debug the issues better. Uh, I mean, that's my approach. If you have any opinion or any suggestion, I'm very interested about this.
Uh, yeah, it's you point out an important issue that I don't know how much we have documentation about compaction. It's the first thing I like I raised when discussing it with other maintainers was that do we have any documentation that explains what is the expected behavior of compaction? Does it compact on the when you compact on X revision? Does it mean that X is available or not available? Like the +1 -1 errors, and I don't think it's clear. So like I like personally, like for me, I would love to make sure that we improve the documentation about compaction. So not only like maintainers can agree how it should work, we should make sure that it's clear for everyone. Because if we don't document it now, the next maintainers will not know what we were thinking when we decided it.
Yeah,
Yeah.
and like I agree. The compaction thing is like I've been trying to understand it better myself. Um, I think the issue itself provides a lot of undocumented context in like through the maintainers. So I think reading the issue helped let me understand it quite a bit. And there's also a document which Marek just suggested, like just explicitly documenting this stuff. That's what this is trying to do, and it's also trying to brainstorm a couple of things of around how to evolve the behavior in itself. So this is something that's helpful to look at for sure. Um, but yeah, the this failure, at least to me, looks like this issue for sure.
Yeah, and the unfortunate thing about robustness test, if there is a new failure, and it starts like when we every time we expand, surface of what we test, like here with compaction, and there is a new failure, until we fix the underlying thing, it's there is hard to get other signal because it will dominate all the errors. So we need to slowly like I mean, we need to slowly like fix this issue and then look at wait some time and look at again for the results. And in this particular issue, there is no huge rush to fix it, at least in, I think, opinion of maintainers. The reason is that we have confirmation this issue existed for a long time, like at least 3.3, and like if it impacted people, or there are stories. I think Wenja told one story that when she joined etcd team at Google like 5 or 6 years ago, her first task was to find why there is a missing event on the watch. So there is a lot of trivia, but like outside of people finding it occasion or maybe trying to find occasionally on sync in production once, it's very, we don't see enough people complaining on it, and we don't see evidence that it's a new thing. So without it being a new regression, we are not in a rush to fix it, and we want to make sure that we do it right in a way that is documented and clear for everyone why we made the decision that we made, and that we can move forward to, like, when everyone knows the issue and understands it, we can go dig deeper for like advance our like understanding as a whole community.
Yeah, and so another thing that's like it was helpful for me to understand was figuring out when a robustness test failure is more important than others. So I think the one criteria that I have started to look at is, okay, we have a legitimate failure in robustness tests, but is this like how much does this affect Kubernetes, right? Because one of the biggest consumers of etcd is Kubernetes currently. So if it's something that's critical to Kubernetes, then that's a fix that we should be spending more time on. For example, this one, the one that we just spoke about, which is dropping the delete event. It's definitely important to Kubernetes because, we rely on watch mechanisms quite heavily, and a delete event should definitely not be missed. But the reason we don't see it that often is because compaction in Kubernetes is also run by not exactly a controller, but pseudo controller logic internally, and it happens on average 5 minutes. Which seems often enough, but we still don't end up seeing it all that much. Um, uh, but yeah, and also I was looking at, so there are two failures. One is with etcd low traffic, and one is with Kubernetes. The other error message that I was talking about earlier is linearization as timed out, which we see here. So this is what might happen a lot of the times. And this is because we use a tool called Porcupine to verify linearizability. So, and the way we do it is we take all of our event history, not all of our event history, but we take our event history, patch it in certain ways, and give it to Porcupine. And validating linearizability is a NP hard problem. Like it can get quite expensive quite fast. So because of which we also prune a lot of our event, like we don't consider error events in our history, for example, because of that. It would be super cool to have it because that would make things much more concrete, but we just can't afford to have it because you'll just have that many more timeouts. So this is the tool in case anyone's interested.
Yeah, I'm unhappy that this error started showing up again because I invested a lot of time to make sure it doesn't happen. And I don't understand why it's happening because the pruning of history worked, or maybe reverse. It looks like the pruning of history didn't work in this example. Like if you look at the linearization, it shows that it didn't resolve correctly, like the pruning didn't work correctly, and I don't know why. But finding why is painful sometimes. Or yeah, I mean, yeah, exactly. If you I don't think this is correct visualization. The correct one, if there's a timeout, it will show you jump to the error.
Oh, okay.
Because Porcupine treats both errors and timeouts as unfinished linearization. So you will, if you open the linearization that's timed out, you would see the button to jump to the first error, and if you do that, then you would jump to the latest, like how far it went with linearization. So you would need to read.
I just hadn't opened the right one. Let me open the right one and see. Yeah, jump to first error.
Yeah, so this is caused because there were a lot of concurrent requests, and it's hard to guess their order. Oh, so many lists. Oh no, this is interesting. So lists should be simple to linearize because any path through them should be good enough. But possibly there is some error after the lists or something problematic after the list. And the fact that there are a lot of lists before the something problematic means that it needs to validate all the paths and like how many and factorial of n of concurrent.
Yeah.
So I think we need to number of concurrent clients.
Yeah, I can see updates concurrent with lists, and
I mean, it's timed out on linearizing the lists, so it means that there is we do too many concurrent lists. We need to reduce. I mean, sometimes this is the anti-hard problem. We need to sometimes reduce the n. And in this case, I would reduce the n. This is the high traffic one, so we should reduce the n in number of clients in high traffic case. Unfortunate, but like. We cannot, this is a limitation of the approach we are using. We cannot have infinite number of clients doing concurrent requests. We can only have like as many as we are able to compute history, and due to factorial complexity, we cannot do much. And each client counts.
Yeah, I'm trying to open VS Code, but it's just like, okay. I was thinking if we can just look at where the traffic is being generated in the code, and be
I mean, you could reduce it yourself. It should be in traffic because on the top traffic. Yeah, so here the high profile, low profile. At the top, the two structures you have or two variables. High traffic and low traffic profiles, and one says there are 8 concurrent clients, and the other says there are 12 concurrent clients, and the 12 is too much apparently. I don't know. I mean, we could guess a number.
5 and 8.
No, I mean, in the test that you had, if you look at the name of the test, that was the high traffic ones, which means the 12 is too high. Like n factorial is pretty big number.
But I'm assuming we don't want to change the low traffic client count.
The smaller step we do, the better. Like we should do just like it's better to just, for example, reduce it just a little and then rerun and see how it works out, and then do another step. So like small steps are the best in this case, because we want to benefit from multiple concurrent clients. We want, like, this is a huge thing. We want to have as many clients as we have, but it's unfortunately validating our assumptions of what are the maximal clients that we can have at this particular time takes a lot of time, because we run the tests only once a day for like 3 hours. So
Yeah. Does anyone want to take this up, making this change?
Can you start with 10? There was 12,
Okay.
maybe 10,
Yeah, sounds good.
and we will see.
Any volunteers to do this?
Yeah, and you can send, like, I will approve it immediately. Like,
We can do this like off the call also in case anyone wants to. Otherwise, we can do it. No worries. But this is what we need to look at. Under test robustness, look at the traffic. Also see if you can sort of figure out what these parameters are and what they're doing. Also, if you're interested, we have a folder called validate. So this is where all the actual tests, all the actual validation of the histories that we have occurred. So when we search for broke was guarantee, this is where that logline is coming from. And you can look at like other log lines as well to sort of figure out what logic is being executed and what to look at if you come across those log lines. So if you want broke was guarantee, this is the file that you need to look at, validate watch. And similarly, you have the third one that I spoke about was serializable operations, which be here somewhere in validate.go. But yeah.
I think validate is the top one. So I go with convention of each directory has the main file, which is called the same as directory. So the entry point is the validate and return visualize.
Yeah, so there you go.
Yeah,
that's
at
fine.
the top.
Yeah. And if you're interested in the pruning, not pruning, but some patching that we do, all of that is here. Any question that anyone has so far?
Okay, maybe we can stop on investigating now, and maybe you can discuss some improvements. So Madhav, you had a very interesting PR that you sent about changes
Oh,
to
yeah. Oh, yeah. Okay. That was a very interesting, like that was a lot of fun. So I'll show you what happened. Not this, but just so that it opens something. This is the one. Is this what you were talking about?
yes.
Okay, so what we're trying to do here is, so the context behind this is we're trying to mimic how Kubernetes calls into etcd in the robustness tests itself, so that we are testing the exact same thing that Kubernetes is assuming of etcd. All of these were very unsaid assumptions before, but we're trying to codify it in the robustness tests right now. And the way Kubernetes receives events from etcd and then passes them is a very specific thing that it does. So if you look at I think I might need to open that.
Maybe you can open
yeah,
just the row. Okay. Oh.
there you go. So this is Kubernetes in the Kubernetes repo. This is the storage layer, and we are looking at how the API server is calling into etcd and also receiving data from etcd. So whenever we open up a watch against etcd, that is whenever API server opens up a watch, it receives events and it passes these events using this method called parse event. And it has an explicit if condition here, which is if the event isn't a create event and something called the previous KV is nil, we just error out essentially. Uh, we can talk about what previous KV is a little bit later, but the idea is we want to explicitly check and test for this if condition in our robustness tests as well. So if I go back to my PR, which is over here, so I'm essentially checking if the event is a create event and the previous value is not nil, we do some error handling. And at the same time, I also want to validate. So the root cause for that if condition, the reason that it was added in the first place was because one of our maintainers discovered this comment in the HCD protobuf, which is yeah. So previous KV can be nil if it's already been compacted, essentially. So what previous KV is, it's the previous version of the key value that is being returned. That can be nil if it's already compacted. So what I was trying to do was figure out how we can test for that condition in the robustness test itself. So in robustness testing, we have this concept of a replay. So we have the state of HCD at each revision that we are sort of documenting. And then based on the revision that you pass into the replay, you can get the state of HCD out of that. So let's say you have revision 2, you have A equals 1, B equals 2. Revision 3, you have A equals to B equals 4, and so on and so forth. So you can say replay dot at revision or whatever that method is called. And you pass in 2, you'll get A equals 1, B equals 2. So you can get the state of HCD at that revision, essentially. So my idea was, can we get the state of HCD from the previous revision, check if it's already been compacted, and then check if previous value, like previous KV is nil. But we cannot do that. And I realize, and Malik also confirmed that with his comment, which is the way we're generating events and the way compaction occurs is kind of independent. And the reason we're able to validate this event is because all of them are serialized in the write-ahead log at the end of the day, because the write-ahead log is what is being shipped via RAR. But compaction and the way we're generating events aren't serialized through the wall. So now we need to figure out how, like, what is the right way to essentially do that. Um, uh,
Yeah, I'm thinking because you reminded, because the compaction is both user visible linearizable operation. So what is being able to set and treat what is the compaction revision? So what is which translates what is the window that HCD has the history of. So compaction allows us to cut the window, and the definition where is the window is linearizable, which means it's immediate, like it's correct immediate. We can assume like it's order and order it based in other requests. But the problem is that compaction itself, so the operation of cleaning up the revisions in memory or on disk, it's asynchronous, because as long as we simulate to client that those revisions are not available, we can do it whenever we want, and in that way we can save time, or like we can optimize it, or we can do it at slower pace that is not as costly as like doing a whole like huge cleanup at once. So because of that, we don't know at all when the compaction can happen, like or we don't know at all when the revision will disappear or priv QE will disappear for the watch.
yeah,
It
that's
could be.
true.
I thought that it would be you could do it based on serializability. So
Yeah,
serial or based on serial. So based on the fact that you can find the time when the watch was generated by a server, and find the time when the compaction was executed, and do it, I know, based on wall, and try to compare it. But you don't know when the compaction was really executed. So there is no time that you could find where this would be. There is no time that you can guarantee when the PrivKV is available or not. I think the only thing you could test is that until there is a compaction request, if all the events that were generated should have PrevKV. But also this is not true, because you cannot observe when the event is generated. You can only observe when the client receives it. So we cannot do anything. But by method of elimination, we like prove that you cannot do any PrevKV guesses on PrevKV. And let's say that's okay, because Kubernetes uses PrevKV, and it's critical for PrevKV to be correct and existing. But Kubernetes has also a mechanism that will detect if it didn't get PrivV when it should have get PrivV because of compaction, and it will just restart the watch. It will reinitialize the watch cache, I think, which is a correct behavior, but it's not great because it's a downtime technically for watch cache. You can, like, API server will not be able to serve requests from watch cache if it's not initialized, so which means downtime, which is okay as long as it happens very rarely or in extreme cases, and someone measures SLO and provides some SLO on API server. So when it happens, someone will just like measure and say to us at some point, oh, like it worked, or as long as it works good enough, it works. But when I know people start pushing Kubernetes and etcd into strange scalability dimensions, it might pop out again. I looked somewhat how the fixing it would look like, but it's very hard. Like, it's hard. Like, it's. I think I have a draft implementation, but the overhead or computational overhead or of guaranteeing that the PrivTV exists is pretty big. The alternative, or at least the approach that I wanted to take, the alternative would be to change the definition on compaction to guarantee that compaction stores not one, but at least two keys, which would be not require a lot of compute, but it will increase storage requirements, which is a trade-off. And I would be willing to take this trade-off when I would be able to have scalability testing and prove that this is a good trade-off to take. But until we can push and prove that etcd, and as long as we don't know how hard it is to push etcd to give it, and we don't see it in production, at least in most clusters, then it's okay. I mean, at my work, I see it more and more often as people run pretty big, as I support pretty big clusters, like above 5K nodes, like, I don't know, 10,000 node Kubernetes clusters and bigger. I encounter it more, but I don't want to push a solution on community because I know I run big clusters. I think I'm more and more interested into having in two things. One is having the scalability or performance testing of etcd, official suite of performance testing of etcd, being there is an effort that James created an issue for and started slowly working on it. And the first thing is to define Kubernetes etcd SLIs, which will define what we want to measure. and then define the SLOs, which say what are our targets, what we want to guarantee to community, and everyone can chime in and decide, oh, HCD should have this and this performance, or we could measure what is the performance of HCD and say, oh, we want to target improving this measure, but not this one. So we can agree everyone and have a continuous testing of it. And then when we have this, we can include it again in the contract. So the contract that we have, and we can put it into robustness tests. Like if we have a contract that I know HCD guarantees that it returns, I know pref QV up to 100 QPS or like whatever, like some number of performance, then we can do that. Then we can test it. But we need first to drive the argument. So if anyone is, I know, less passionate about correctness or like distributed systems, but more about performance, then there is also a lot of work to be done in that area.
Yeah. I was also looking at what the error from the parse event is. It just sends an error event on the watch channel. So I'm not sure if it leads to reinitializing the watch cache totally.
Yes, 3 errors on watch. I think. I mean, a client will. If there is a client on watch. I mean, there is since last change by Madhav that resulted in breaking of watch. There is no client to the watch other than watch cache. But before that, a client would immediately break the watch if they receive an error. And with watch cache being the only client, I think it accepts 3 times the error or something like there is some retry logic or whatever. Maybe I'm lying. But last time, or when I investigated the issue that I mentioned with the direct watch, I've seen watch cache reporting 3 times an error that there is a missing pref QV or maybe it's missing compaction. I think it was compact or whatever. Like there are 2 levels, like normal error, and I think the pref QV immediately causes the watch cache to reinitialize. I think that this is the case. So, to clarify, normal errors can happen, I think 3 times, but this error, pref QV, immediately causes the recreation. Based on my like from my memory, as I observe it in production.
Yeah, I'll also just take a look at that. See if I can understand it better. Okay, we are 9 minutes out. Does anyone have any questions, comments?
I don't know, not to put people on stand, but I know Faeka is here for the first time. Wanted to ask if everything is clear and whatever we can. I mean, I wanted to welcome you. Thank you for joining, but I wanted to ask if there's anything else we could make sure to make it more clear or.
Yeah, I hope I'm audible. So yeah, I mean, I've been attending the robustness test meeting for quite a while, but it has always been quite confusing. So I'm just wrapping my head around like what exactly we've discussed. But yeah, thank you so much, Madhav and Merrick. Like the way you all went through everything and iterating through the basics and maintaining the clarity, it all like really helped me to stay engaged and follow along with what you were trying to demonstrate. And like I said, I'm still trying to wrap my head around most of what we've discussed because I'm just trying to understand how we approach all of these errors from scratch to achieve the results that we want to. So I think most of what Madhav covered, like initially covering what are the types of errors and talking about the linearization, broken watch, serializable operation, and all those things, they were something I followed along and I tried to search more. And with time, the speed went high. So I'm still trying to catch on things. So it was quite difficult by the end of the thing. But yeah, I'm trying to catch more things with the time. So I learned a lot of valuable skills like efficiently skimming through the documentation, what you all were doing throughout the time and analyzing those graphs and identifying those errors. and also leveraging the fail points and pro all these things. So I think we should do this more often. And also one thing like feedback or something, I guess we can keep it a little more beginner friendly, like for people like me who's just trying to grasp over things. And also if we can add more docs here for for people like me who is just trying to learn these things. So where can I hit so that I can learn more about it? Like Madhav just opened some documents on the page of HCD where he was skimming through where exactly the meaning of reliable and all these things were. So I was also just trying to Google them and stuff. So if we have a link of those things in the doc itself, I'll be able to directly go and read more of it.
Thank you so much for feedback. I think, yeah, you're totally right. We in Madhav used a lot of vocabulary that is specific to the area, and just recently I needed to even document on one of the bugs or PRs that I was discussing, I think, with Madhav. What does it really mean to be serializable, and how this is really how this definition really is overused also and changes depending on where you read it or depending on the project that you read it from, because etcd a little bit misuses it in its API. So I think that would be definitely useful to add, I don't know, even to our document, like list of top most used words and their meaning, or list of most important documentation that we are using or terms that we are referencing. If we had like just top 10, then we would, I think, cover 80% of cases and it should make it more clear. Does it make sense, Faika?
Yeah, definitely. That definitely makes sense considering like the approach that I would follow. That would be very helpful if we do that. Yeah. And also this idea was great. Like when we have multiple hosts, it also makes it really fun to understand the way everyone follows and approaches it. Like from since the previous robustness test meeting, I've been hearing you and it was like really fun. And now if I see Madhav and in the next call, it would be someone else. It's fun to see the way they follow along and to follow the approach and look forward to it.
Yeah, it was a great idea. I cannot take credits for it. Thank you, Sue, for suggesting this.
You're welcome. I think I got that idea from you, actually.
I don't know. I will not take credit. I don't know where it originated. I think the more we can talk and communicate and discuss things and brainstorm, I think that the more great ideas we can come up with.
Yeah, thanks, Faika. I think that was honestly exactly what I struggled with, but thank you for putting it into words. I think it's nice that we have a group here that is taking interest. So everyone doesn't need to go through that initial barrier. Hopefully we can make it easier. Yeah. Hopefully you can also run the meeting sometime soon.
Yeah.
Okay, I think we are almost at time. Oh, sorry, someone's on mute.
I have a question. So right now there are a lot of failures just caused by this compaction bug. So when we actually look at the dashboard, it's just a lot of red. I don't know, for future investigation, you just have to go through a lot of these noises or these past like investigated bugs.
I would love to clean it up as fast as possible, just to get back the signal. I'm like, the problem is, what should we disable? Like, what can we relax for the meantime to now to or what alert, basically for me it works like I know alerting, what alert we can silence so that we are not, we don't get alert fatigue. So can we wait a little bit until like the we incident with the recent issue is mitigated, and we I know as a community we decide how compaction should work, and we decide on we write the tests that we are discussing the testing exactly, and then we implement the fix. Should we and backport it to it really, should we wait for that? Maybe it will take too much time. So can we, so the second, so if we don't want to do that because it will like I know take a week, another week for us to get nice clean dashboard, so maybe we could write somewhere like relax the testing or silence specific test. So I didn't had too much time to work or to think about this, but I think like considering I know either disabling compaction for short again for some time until we get it working is an option. Other case would be disabling the watch reliability guarantee for this specific case. It's not easy to, I mean, it's easy to make mistake on overfitted, but maybe we would be able to disable just for this specific case. So for example, if there is a reliability broken on a watch event that is a delete that has a matching compaction, we could try to do that.
I'm thinking maybe we can separate test with compaction, test without compaction, and then when we don't have enough time, we just don't take a look at the failures with the compaction.
Yes, I mean, sounds good. If you want to send a PR, I think it's okay idea until we fix it.
Okay.
Okay, we are out of the time. Madhav, do you want to, I know, finish or should I?
I think we're good, Marek. Go ahead.
Okay, so thank you everyone for attending, and hope you had a great time as we did. And hope we will see each other in 2 weeks. So have a great local time. See you.